Welcome to this demonstration of the buck chopper with feedback. Please note that this function, along with the boost chopper with feedback, are the most complex functions of the chopper inverter control application. It is suggested to try the high side switching buck chopper before working with this function in order to understand the basic features and functionality. As you see, I opened the chopper inverter control application. Under Function Selection, select Buck Chopper with Feedback. This pop-up window advises you to set the meter E4 to low or high in order to make this function work. You can set meters at the 9063 at the right side of the LVDAC window, like this. Functions using feedback will always have that kind of pop-up window. Just read it and do as it says. Now let's take a look at the settings you have with this function. Switching frequency up to 20,000 Hz. Command input, knob or analog input 1. Command, %. I'll talk about it later. Controller proportional gain, KP, from 1 to 100. Controller integral gain, KI, from 0 to 20,000. Feedback input, you can choose E4, I4, speed, analog input 2, and E4, I4. This input decides what you want to regulate. In other words, this function can regulate voltage by E4, current by I4, speed through digital input A and B, whatever comes in by analog input 2, and finally, power in watts, the product of E4 by I4. Feedback range sets the maximum value you can get for the specific feedback input you have chosen. Feedback filter cutoff frequency, a variable low-pass filter acting on the feedback input. Acceleration and deceleration time for smoother command variation. Q1, the switching transistor. You can choose PWM or always on or off for troubleshooting. Status indicates if the function is started or not. Note that it will stay gray, preventing you from starting the function until the meter E4 is set to low or high, here. Here's the knob that controls the command value, the start-stop button, and finally the meter here that gives you the value of the duty cycle applied to Q1. Let's get back to the command percentage line here. This line sets what will be the output value of the buck chopper in percentage of the feedback range. For example, if the feedback input is E4 and the feedback range is 70, then the output range of the buck chopper will be from 0 to 70 volts, and a command percentage of 50% will ask the buck chopper with feedback to maintain 35 volts on the output no matter the load. If the feedback input is speed, and the feedback range is 2000 RPM, then 50% here will ask the chopper to maintain a speed of 1000 RPM. As always, here's the electrical diagram of the function and the Show Connection button to help you connect your hardware equipment. For this demonstration, I will use E4 as the feedback input on a variable resistive load. This means that the buck chopper will regulate the voltage read through E4. This implies that you need to connect the meter E4 of the 9063 at the load if you want the chopper to regulate. It is exactly the same principle for the other feedback inputs, like speed or I4. When all your equipment is correctly connected, start the application. The yellow curve here is the input voltage, the blue curve is the output voltage or load voltage, and the purple curve is the duty cycle, also available directly here in the meter. Finally, the red curve is the current through the load. As you can see, the command asked of the chopper is 50% of 70 volts. This means I want around 35 volts at the load, which is exactly what I get. Now, to observe the regulation process, I decrease the input voltage. As you see, the duty cycle automatically increases to maintain 35 volts. If I increase the input voltage, the controller automatically decreases the duty cycle to prevent having high voltage at the input and maintain 35 volts. The regulation process works great. I can vary the load, increasing the current in it, and still, the load voltage is maintained at 35 volts. You can try various proportional and integral gain configurations to see what happens to the output voltage and regulation efficiency. Depending on the application, some settings might be better in one case but bad in another. Try finding the best setting possible. Finally, I suggest you try other command percentages or another feedback input like speed, for example, and see the results. That's how the buck chopper with feedback works.